So I know we have a little bit of lag. Has it switched? Not yet.
Oh, is that the tornado siren?
Yeah, first Wednesday of the month.
Yeah, no, it hasn't switched yet.
Okay, it might take a minute.
There we go. It's live.
Awesome. Well, hi everyone. Welcome to our first attempt at a Marshall W. Ulrich Planetarium live stream. We're going to take a few minutes and kind of introduce ourselves. And we have some interesting kind of current events that we want to share with you guys. But the main focus of today is going to be the Ask an Astronomer. And so if everyone wants to, or if you have any questions or topics, feel free to leave them in the comments, and we will try and answer all of the questions we get. So I guess I'll start off introductions. I'm Jessica Harrington. I'm the director of the planetarium, and with me I have three of my student workers. We'll start, I guess, with Lindsay.
Hi, I'm Lindsay. I'm a physics graduate student here at UMD.
Josh?
Hi, I'm
Or Eli?
Eli. Oh, sorry. I'm Eli. I am a physics undergraduate student here at UMD.
Hey everyone, happy Wednesday. My name is Josh. I am also a graduate student at UMD and a fellow planetarian. Good to see you all.
So, since this is our very first live stream, there is bound to be some technical complications. We're also still trying to get a feel for how much lag time there is between what we're saying and when it comes up on the stream. So it may be a couple minutes before we answer questions or get to whatever questions you ask, as we're still just trying to learn the software and how it works. But Eli is going to be watching the comments, and will let us know your questions. But I guess to start, we each have some interesting current events that have been going on. And who wants to go first?
I can go first. So the kind of current event that I chose to talk about was tomorrow, April 2nd, marks the 175th anniversary of the first surviving image of the sun. So it was taken on April 2nd in 1845 by two French physicists. And that was really early on in the development of photography. So it was taken with a really old method of photography known as daguerreotype. And that's where you had a silver plate and it was covered in iodine. And once the iodine was exposed to the light, it would, just kind of burn the image into the plate. And that's where you had your photo. And I just thought it was really interesting that it was taken so long ago. And I will share my screen so you can see what the image looks like. It is not much compared to the images that we have today. And I hope did that come across, guys? Can you guys see that? So yeah, this is the image, and like I said, taken 175 years ago, daguerreotype photography, and this is the image. One of the things that I thought was really interesting is you can still see sunspots. I hope my mouse is also visible. I'm kind of outlining those right now. Those are sunspots right there, kind of explosions on the surface of the sun that then cause a cooler area, which is why it's darker. And those sunspots, like I said, I think that's kind of insane that it was able to be captured by such a primitive form of photography. And I can't imagine how excited those physicists probably were to have obtained this image with something so new and kind of such a crazy process that goes for it. So I thought that was really interesting, and I wanted to share that. I'm going to figure out how to stop sharing my screen.
There should be a red button at the top that says stop sharing.
There we go. Okay.
Yeah, like I said, we're learning. So, but that's the fun in doing live stuff. You get to see us as we learn on the spot some new things. Awesome. Who wants to go next? I guess I can do one of mine real quick. So let me switch over. One of the really cool things one of the cool missions that I've been paying a lot of attention to is Mars Insight. It's one of the newer landers that's on Mars. And so you should all be seeing a nice picture, artist rendition of that. So Mars Insight launched back in May of 2018 and landed on Mars in November of 2018. And it had a couple of big goals. One of the things that it wanted to do was measure and see if we could sense Marsquakes, so like earthquakes, but on Mars. Because just like we use earthquakes here on Earth to try and learn about the interior of the Earth, we wanted to use these Marsquakes to learn about the interior of Mars. And so it has sensors to do that. It also has what's called a heat flow probe to try and figure out how hot it is inside of Mars. And that's also interesting to us because that tells us kind of the geological history, what Mars has been through over time, and helps us better understand how these rocky worlds developed and changed over time. And so it's now over a year so far on Mars, and there have been some really interesting things that have happened. One of the first things is we are detecting Marsquakes. Currently, I believe we're up to detecting about 2 of those a day, which is pretty awesome. And it turns out that we're finding or detecting more of these quakes than we expected, and they're also a lot milder than we expected. And so there's still a lot to learn as we try and understand why our initial models were off and figure out what's actually going on there. And then another thing that we've been kind of sensing is magnets. So you may know that Earth acts like a big magnet. Well, Mars did too in its past. It's not anymore, although some of the rocks deep under the surface still act like kind of smaller magnets. And so we've been trying to sense those and measure those. And it turns out that magnet that we're sensing is about 10 times stronger than we thought it would be. And so that's another kind of big mystery that InSight has found for us in its first year. And there's still a lot to do. One of the big things that's going to take a couple of years is trying to better understand, like I said, what the inside of Mars looks like, kind of that core mantle crust, just like Earth has, but how big they are, how hot they are. And one of the ways we can do this is by sensing how much Mars wobbles as it spins and orbits the sun. And it's, like I said, it's going to take us a couple years to really do that, but that's one of the further missions that we're working on over the coming years is seeing how much Mars wobbles to give us more insight into what's going on there. So yeah, that's a little update on that. InSight has its own social media, and it's really cute and gives fun pictures and videos of things that it's doing. So that's something that I enjoy following. Curiosity also has one, and is really adorable. Except when it's singing happy birthday to itself all alone. That made me a little sad, but NASA has really been fantastic with having social media for their missions and really kind of giving them life, which has been great. So yeah, Eli, do we have any questions yet?
We do not have any so far, but I do know that there is a little bit of a delay, so those might come across in a few seconds.
All right.
Do we want to save them for the end and address them, or give a little grace period after each presentation?
I'm not sure.
But we can see if any come across and when they do, and we can tackle that in a bit.
Yeah, absolutely. So again, leave any questions you have in the comments. And especially if you're having any video or audio issues, let us know. Because again, first time doing this, this is kind of new for a lot of us. So there are going to be some technical issues for us to work out. All right, well, Lindsay, Josh, I know you both have something cool to talk about. Who wants to go next?
I go next.
All right.
So I looked into a recent story about intermediate mass black holes. There has officially been a confirmation that there is a intermediate mass black hole that exists. And the reason that that's important is because of one of the ways that we think black holes evolve. So we know for sure that there are black holes that are what we call stellar mass black holes. And we know for sure that there are black holes that are supermassive black holes. Those are at the center of galaxies. But we really only know how stellar mass black holes form. So they form when a very large star explodes or supernovas. And then if the remnant after that explosion is larger than 3 solar masses, it can't hold itself together, so it keeps collapsing into a black hole. And then you have your stellar mass black holes. So how do we get from stellar mass black holes all the way up to supermassive black holes? And one idea for that is that the smaller black holes keep merging together and merging together and merging together until we get the supermassive black holes. And so it would make sense that if that is the case, that we would find some black holes between stellar mass and supermassive that are kind of on their way to becoming supermassive black holes. And so this particular black hole or intermediate mass black hole was found at the center of a star cluster. We think that there could be more intermediate mass size black holes in like intermediate mass size galaxies because we know that the size of the galaxy or the mass of the galaxy is related to the mass of the black hole that's at the center.
And that's actually related to your research, right?
Yes, it is. That is what I'm researching. I'm trying to find my own intermediate mass black holes.
Yeah, awesome. Well, Josh?
Sure, why not? All right, hello everyone. Today, what I have to share with you is, here, let me pull it up quick. Maybe that might be best. Share my screen here quick. Present. Coming across okay?
There it is.
Perfect. All up.
Yep.
I can see it in some of the reflections of some of the glasses, so that's
Sorry
a good
about
sign.
that. Yeah.
No, it's all good. All right, so today we have gas bubble bursting Uranus. Pun intended or not, take it how you wish. But what we've got going on today is kind of a special look at this planet Uranus. In the past, there has been a lot of research done around the quakes on Mars, just as Jessica had already shared with everyone. Lately, Cassini had dove into the surface of Saturn for the only and last time, but Saturn was very much under scrutiny, research, investigation from Saturn, looking at Saturn's rings from Cassini on Saturn's rings. The jet streams of Jupiter have been researched by the probe that's currently circling around Jupiter, and then the heartbeat of Pluto is something that's also been researched. But it was actually 34 years ago that Voyager 2 went on a flyby around Uranus, and Voyager 2 went around many other planets. But recently, this planet was revisited because of all the other missions that have been going on, such as Cassini. Having Cassini gone to the end, people have actually been going back into data and then going through it with a fine-tooth comb. And the two researchers, Gina A. DiBasio and Daniel J. Gershman, went through the 45 hours worth of data from the Voyager 2 satellite that flew by Uranus. And what they found upon doing that was a 60-second long section. Through 45 hours, they found a 60-second long section, which there was one of the tools that read how strong the magnetic field was. It found a spike in that 60-second long section. And so what Gershman had suggested was that possibly it was a plasmoid, which is this fancy name for a giant magnetic bubble. And within that magnetic bubble, the possibility, and likely the possibility, of supercharged gas particles. And so they do find this around other planets as well. And they do study it here on Earth. To what degree the gas bubbles are similar between different planets, I'm unaware of, but this is the thread which you can pull on later and see where that leads you. And depending on how long the leg is, I've just clicked to a slide and hopefully it's looping. And this is a slide which is kind of showing the orientation of Uranus. It's just a computer generated model. The yellow arrow, if we all can see it, right? That's on the live feed.
Yep.
Cool, perfect, awesome. So that yellow arrow is the direction or the face which is towards the sun of Uranus. And then on the bottom right-hand side of Uranus, there is a blue arrow, which is the axis which the planet spins around. And so what you're also seeing there, that mess of spaghetti with it looks like the moon Miranda as the meatball of it all, that is the magnetic field lines around the planet. So what happened when Voyager 2 went through those magnetic field lines is that they found that there was a bubble in there, a strong magnetic field, which spiked one of their instruments. And so they're studying this. And after doing an analysis on how fast the orbiter Voyager 2 was traveling and how long that it measured that magnetic field spike, they roughly suggested that this gas bubble is around 22 times the size of Earth. So it's a very large gas bubble, very large magnetic field bubble that is around or near the surface of the planet Uranus. Is it now? I don't know, because one of the things that they do study with these plasmoids, these magnetic field gas bubbles, is that when this gas bubble leaves a planet, it actually has a great effect on the contents of the atmosphere, the air circulating around the planet, and it can change the dynamic, the air, and the way that the cycles happen near the surface, the weather. And so that's something they're currently studying, such researchers as Gina A. DiBarcio and Daniel J. Gershman. So if you would like to know more about that, over to popular science. What I've shared with you now, I've pulled a few bits from here and doing some other research, but there is popular science, which you can look from, and that has a longer article, and then also space.com is another place you can go, and obviously you can see where I got my graphics from. So that is what I have to share with you all today. Thank you very much for listening, and hope you have a lot of questions.
It's always fun to talk about gas blobs from Uranus. I mean, you can never not giggle when you say that, right? It's one of the things that we definitely embrace and encourage, the giggling, when we talk about that particular planet, because it's going to happen no matter what. All right, Eli, do we have any questions?
So we have one question and then one kind of comment that I think we can look at later about where we can post the link to our live stream. So not
Awesome.
exactly a question, but we will take care of that later. From Amy Coretta, we have when will the sun ever die out?
Hi, Amy. So that's a really good question. So our sun is currently in the midst of its life. What's going on is at the very center, it is turning hydrogen into helium, and that's what's creating all of the light and heat that's coming from it. And so a star will continue to live as long as it has hydrogen to turn into helium, because that's its fuel source. That's where it's getting its energy from. So for our sun, it's about 5 billion years old and is about halfway through its life. So it has another 5 billion years before it reaches that point where it starts running out of that fuel. And when it does, something interesting is going to happen. When it gets towards the end of its life and it starts running out of that hydrogen fuel, it's actually going to expand into a red giant and engulf the planet of Mercury, Venus, probably Earth, and probably Mars. So that is definitely the time period when we need to, find a new home. And then it's just going to kind of puff out those outer layers, leaving behind this really beautiful gas cloud called a planetary nebula. And what will be left behind is the core of the sun that's just going to shine like a hot ember called a white dwarf. And that's, like I said, going to be in about 5 billion years. So we have a good long while before it happens. But that's a really good question. All right. Well, while we're waiting for any more questions to come in, I have one last topic that I wanted to talk about. And that, as you may have heard, is our new mini-moon. So we have a new moon. So this little mini-moon was found on February 15th by the Catalina Sky Survey. So this is a survey of telescopes that closely watches asteroids and comets that get near the Earth, because we want to know if anything big is heading our way. And so this is one of the several different teams around the world that monitor things coming towards the Earth so that we can know if we're in trouble. Well, on one particular night, they were watching and they saw something that was a little strange. So you can see this little video here, this green circle. You have this little object that's moving very quickly against the background of stars. And when they checked against the catalogs they have of asteroids and comets, that didn't match with anything that we knew existed. Or that we have kind of charted. And so as they watched over the course of the night and watched how it moved, they could start to figure out its orbit. And by doing that, we realized that this thing is orbiting around the Earth. And so this is our new little mini-moon. Now, this is actually not a new occurrence. This sort of thing happens fairly often. It's expected that we have mini-moons all the time. The thing is, these are very, very, very small objects, and so they're not easy to find. Like this one was just pure coincidence. They happened to be looking at the right place at the right time, and they saw it. And this is actually the second mini-moon that we have found. The first one was found in 2006. And orbited around the Earth for about 18 months. It was a 3-foot wide asteroid, so a small little chunk of rock that got caught in Earth's gravity. This new one that we found is more potato-shaped, about 6 feet by 11 feet, also rocky asteroid. And we think it's actually been orbiting around the Earth for about 3 years. We just are now happening to see it, and it's not going to stay around here forever. Our models of kind of its orbit and how it's moving predict that it's going to fly off and away sometime this month. And so we found it kind of right at the end of its time being our mini moon. But yeah, so that's exciting. All right.
So we did just get another question come in from Kathy Roller Harrington. And the question is, it's a pretty big one. So Pluto, planet or not? And Jessica, I know you're passionate about this one, so I will.
I am, and that's why she's asking. That's my mom. Hi, Mom. So this takes a little bit of explanation. So when Pluto was first found, back in 1930, I believe, sometime around there, it was the first thing that we had found out past Neptune. And everyone was super excited. Yay, great, we have this new planet out past Neptune. The problem was we knew immediately that it was very different from our main planets that we already knew of, our main 8, because it was much, much, much smaller. Pluto is smaller than our moon, and its orbit is kind of tilted more so than the planets, the main 8 planets. And so it didn't quite fit the size or pattern. But we kept it a moon, or a planet, and that lasted until the early 2000s when we started finding more and more things out past Neptune. And most of the things that we found initially were smaller than Pluto. And so it was easy to say, okay, Pluto's the biggest thing out here, we're going to keep it a planet. And that all changed around 2003 or 4. I always forget dates when I'm put on the spot. And when we found Eris, which is an object out past Neptune that is about the same size as Pluto. And so that started, well, if it's the same size as Pluto, and Pluto's a planet, does this become a planet? And we weren't quite sure. And then we started finding more things like Pluto and Eris around the same size. And so in 2006, the International Astronomical Union got together and decided that they had to make a decision. Were these things all going to be called planets, or do we come up with some sort of new category? And that's what they ended up doing. So they came up with this dwarf planet category for things that are like Pluto. And so that's where we stand today. It is a dwarf planet. And this is actually not the first time something has been reclassified. Back in, I think it was 1900, when the very first asteroid was found, Ceres, it got started off being called a planet. And then more asteroids were found, and they were called minor planets. And then even more were found, and then they realized that there was just a lot of stuff there between Mars and Jupiter, and so they just started calling all of those things asteroids. And so this is something that does happen when we make a first discovery and then learn more. Sometimes you have to reclassify, and it does break my heart, because I did grow up with Pluto being my favorite planet. But the scientific side of me understands. But I will still forever love Pluto. And at least Pluto is the largest of the dwarf planets. So he is the king of his category. And that makes it a little bit better. So yeah.
All right. We haven't had any other questions come through. We're almost at the half-hour mark, but we can wait a couple more minutes to see if anything comes through to account for the lag time.
Well,
and you were right. Pluto was discovered in 1930.
Yes.
Yep. And then I'm going to look up when was it declassified.
I think it was 2006.
2006. Yep. And wow, it does.
It might be the only time that happens on these.
It was, if I'm not mistaken, Neil deGrasse Tyson was one of the big contenders to get it reclassified as not a planet, right?
Yes. Yes, he was.
Yeah. My high school astronomy teacher was very upset at him for that fact.
I was too.
Yeah. I talked to him about Neil deGrasse Tyson one time, and he said, more of a Carl Sagan person. And I was like, why is that? And he's like, because Neil deGrasse Tyson took Pluto away from me. So that was pretty funny.
Yeah. So have you seen any interesting April Fool's pranks yet? I've seen one astronomy related.
I don't think I have.
Yeah, so the one going around that I've seen is about the transit of Saturn across the sun taking place today.
Oh, that's funny.
And for those who may not understand why that's funny, since Saturn is further out from the sun than we are, from our vantage point, we never see it cross in front of the sun. And so it's a fun little April Fool's that I saw going around. I'm sure there will be more coming out.
I was pretty highly anticipating a lot of stuff about the asteroid that is coming close to Earth. Because isn't there one that just recently did or is supposed to be soon?
Close.
Right. Yeah. Right. I was expecting to see a lot about that, but I haven't seen anything on it.
Yeah. I think the last one I saw that they called coming super close was further out than our moon.
Yeah. Though I remember the I'm probably botching the pronunciation, but I believe it was pronounced Oumuamua.
Oh,
It was
yeah.
the really elongated one. It was kind of like a I don't know, like a pencil type shape. And that one, I think it came in between Earth and the Moon, but that was like 3 years ago or something like that.
No, but that one was even more exciting since it came from outside the solar system.
Right. That's what was cool about it. I feel like that's
Our
where it gained a lot of
first
traction.
interstellar asteroid.
Hmm.
So if you have any last questions, put them in the comments while we wait to see if anything comes in, because again, there is a bit of a lag, just a little bit about our plans moving forward. So we are going to be hosting these live streams Wednesdays and Saturdays at 1 p.m. until further notice. We already have some stuff planned for the upcoming week. So Saturday was supposed to be our annual astronomy day, and we're all very sad that we're having to postpone that. But we do still want to do something, and so we're going to have a mini virtual astronomy day for our live stream on Saturday. So that one's going to go a bit longer than our live streams normally will. This one's going to be about 2 hours from 1 to 3. And we have lots of fun stuff that we're going to talk about. Lindsay is going to talk about some of the awesome women in spaceflight. And so we can learn about the amazing women that helped get us into space and to the moon and other awesome missions that they contribute to. We're going to be doing a kind of night sky tour, kind of showing you what's up tonight, how you can find them, some of the fun constellation stories. We're going to be doing a demo of an experiment that you can do from home. Still working on exactly which one. We'll get back to you on that. And then, what was the other thing we were doing? I'm forgetting it. I don't. Yeah, we're going to do more Ask an Astronomer. So more time for you guys to just ask us your questions. And we can go from there. And then next week, next week on Wednesday, we're going to do a program on the phases of the moon and eclipses, because we know that that is one of the school standards, and we haven't been asked about doing something like that. So that's going to be Wednesday next week. And then next Saturday, we're going to teach you how you can be an astronomer from your home and actually take part in real research in astronomy. And be what we call citizen scientist. And so we're going to tell you all about that Saturday next week. So do we have any last questions, Eli?
We got one last question, again from Amy Carretta. Will Earth ever explode?
Not naturally. Not that I know of. No, I mean, we as a human race could mess up and cause something catastrophic. I guess the only other thing would be if we did have something really, 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 really big, like planet-sized, that ran into the Earth. But nothing like that exists anywhere nearby. And with it being that big, we would see it for sure. So probably not. Does anyone else want to chime in?
Yeah, fingers crossed, probably not.
When the sun does expand out to the orbit of Earth, potentially, it will burn us up but probably not cause an explosion.
Yeah. All right. Well, thank you all, everyone, for tuning in to our very first live stream. We're excited to be doing something. We all miss the planetarium, but we know that this is for the good and the health of our community. And of course, we fully support staying at home and trying to flatten the curve. So we're happy to at least still still connecting with everyone, at least through these live streams. If there's anything in particular that you would like to see, you can always leave a comment on one of our posts or one of our videos, and we can see if we can make a show about that. I know we
Or you
have.
can message the Planetarium's Facebook as well.
Yep. Send us an email, anything like that. And all of these live streams will be posted for future viewing as well. So these will be up and available for people to watch.